All right, so I know this has been a lot to take in. There's been a lot of material, but I promise you it is worth it. There are a couple of different ways you can think of what you've learned this week. One is that I've shown you what there is, now you can go do it. But I don't expect you to have like memorized everything that I showed you. Part of the goal really here was to remind you that there are ways to solve these problems, and that if you are running into a problem later while you're cleaning data, at the very least you want to think that you'll know where to look. If you just want to look back at these slides or these videos to find the answer that you're looking for, that's great. You don't have to memorize everything. Or when you Google for something, you're like, how do I make a new variable? And someone says mutate, and you're like, oh yeah, I remember using mutate, right? Or knowing that there are ways to do automation, or knowing that there are ways to edit strings. That once you know that those things are possible, knowing where to look for them is half the battle, and even more important than actually memorizing the things. You're not going to memorize this code until you've used it a bunch of times anyway. And that's not going to happen until you actually get a lot of hands-on experience, which you will get in the homework and the projects and whatever, but that's going to take some time. For now, we just know that these things are out there and you know where to look back for them. One basic thing just to finish things out, there's one more thing that I want to talk about, which is finishing your work. Once you have done your data cleaning, what do you do with the resulting data? You want to save it in some way. There are a couple different ways to save data in R. The save function, you can save many objects. You'd say save my data, and then you tell it the file name to save it to. It will save it as an R data object, and this can store, by the way, many different objects in it, not just necessarily one data set. So if I can do something like, I want to save both data sets, I can say, hey, let's do save my data and also the construction, and I'm going to save it in the file of my data and construction. .r data, and this will save it as a file in my working directory. It will have both of these objects in it, and then when I go back to load that file later, it will load both of these objects into my environment directly. Now, I prefer the save RDS function over save. Save RDS only works with a single data set, but it saves it in compressed format, and so I can do something like this: save RDS my data, data, and then when you load it back in, you don't just say read RDS my data.r data. It reads it in just like read CSV would. So you need to save it as an object, my data, right? So you read it in like that. I prefer this, although I can see why people might not want to use it for a couple reasons. One, if you save something using this format, like if you then try to open it in Tableau or some other format, it won't recognize it usually. Also, if you double click, at least on my computer, if I save data like this and I double click on the file, it will not open properly in RStudio. So this is a bit easier to work with. I prefer this version, but that's just me. Certainly don't feel the need to do that. We could also avoid the R formats entirely, which there are good reasons to do, especially if you're working with somebody who's not using R. If you want to, say, save your data as CSV, you can use write_CSV to save it as a CSV. So I can do something like this. I can do write_CSV, my data, or my_data, my data.csv. CSV is a very easy to transport file. It's not particularly efficiently stored, so the file size might be a bit bigger, but it's very easy to read. It literally just looks like, value, comma, value, comma, value, comma to go for the comma goes from column to column, and then you go to the next line to go to the next row. It's very easy. It's like a spreadsheet written in a text file. And then you can open a CSV in pretty much any software. So if you're going to send a data set to somebody else who might not be working in R, definitely use CSV. It's going to be easiest for them to work with. If you want to get really fancy, there is the Parquet data format, which is pretty popular these days. You need to download the Arrow package to use it, but you can use Arrow : write Parquet and read Parquet. Parquet is a very highly concentrated and compressed data format, which is available. You can, if you're sending something to somebody who's working in Python, for example, there is a read Parquet function there, so you can send them your data in a very compressed format. So if you're working with really big data that you need to compress a lot, write and read Parquet might be good ways to work, and they work in the exact same way as write CSV and read CSV. So that's how we can save our data. Also, along the lines of finishing up our data, please document your data. Write down what it is that you did and what your variables mean. You will thank me later. At the very least, keep a spreadsheet with a set of descriptions of each of the variables that you have in your data. Otherwise, you will forget what they mean, right? If you're like, hey, I wrote down my marital status variable, and does that mean marital status now? Is that marital status ever? Were you ever married, or are you currently married? Which one was it? Oh, I forget which one I made it. Right? So write down what it is your variables mean. It'll be good for you when you look back at your data later. It'll also be very helpful for anybody who comes across your data and wants to use it. In addition to writing down like an Excel spreadsheet of your data descriptions, you can also use the SJ labeled or Haven packages to put labels on your variables themselves. So it will store the information in the data object, and you can, for example, in vtable, load up the descriptions of the variable in it. Yeah, so if you use SJ labeled or Haven to put variable labels on there, then vtable, for example, will generate a documentation file for sharing. And you can use vtable to create variable documentation automatically without having to do an Excel spreadsheet. So for example, you can add variable labels. As I mentioned, I had to pause there, sorry. So for example, this avocado data set that I have from the causal data package has variable labels in it. They are stored in the data object itself. So if I use vtable from the vtable package, it will create this page right here, which has the label of the data that describes what the variable actually is. And in this case, it tells you that, for example, total volume is the total amount of sales that were generated. And then I could take this and just export it. I could use the out option to save this as a file, and then I could send somebody this file along with the data set itself so that they would know how to use the different variables in the data and what exactly they mean. All right, that is it. That finally closes out our data cleaning process. I know it's been quite a journey. There's quite a lot here. And if you're feeling overwhelmed, again, that's okay. We will get some practice in on this. You'll get more used to it, and it will become a little bit more intuitive as we go along and are able to use these tools more and more. Just don't forget, don't lose confidence. You have to be willing to try these things in order to get good at them. You're not going to be good at them the first time. It's not going to be easy to use them the first time. You're going to be banging your head against a wall. Data cleaning is something that can take some time the first couple times you do it, until you get used to it and you get a little bit more intuition on how to do particular tasks. So prepare yourself for a little bit of pain in the near future, but it will be absolutely worth it in the long run. Thank you.